Acceleration is negative 32 feet per second squared. That's S prime prime. And let's just use T. Because acceleration due to gravity, does that ever change? I guess it depends on how far away you are from the surface, but it's pretty much constant, right? It's negative 32 any time of day, right? Okay, we'll say that. Negative 32 feet per second squared. Alrighty. So now we have enough information to start solving this problem. Where are we going to start? We're going to start at the second derivative. If I know the second derivative is negative 32 feet per second, and we're talking about the variable t, if I take the integral of it, of negative 32 feet per second squared with respect to which variable?
T.
With t, exactly. What's the integral of negative 32 feet per second? What's the integral of a constant?
C.
It's not 0. What variable, Clark? With respect to what? Well, with respect to what? So our integral should be negative 32t plus c. Let's think about it. Let's think about this. What's the derivative of this? If I have the first power times, then you subtract 1, and wouldn't it just be negative 32? Couldn't I also think of this as times t to the 0 power? And I could add 1 and then divide by 1. Wouldn't that be the same thing if I'm using that power rule? So now we have this. Now I know what the velocity function should be. This is the same thing as s prime of t, isn't it? Do I know one point on that function? What's that one point that I wrote down earlier? Okay, so when I plug in the time is 0, do I know what the constant of integration is for s prime of t? So exactly, so here is my first derivative. Here's my velocity function. Does everybody understand how I did that? We took the integral of the second derivative. We found a function with c. Then we're going to that point where we know s prime of 0 is 64, and plugging that in where time is 0, I can figure out that 64 equals 0 plus c. C has to be 64. Now the question asks us find the position function. So what do I have to do? Do it again. So we're going to integrate with respect to t, this negative 32t plus 64. What does this become?
There's two sections.
Negative 16t squared plus 64t plus c. And this is s of t equals. Is there a way to figure out what the plus c is? We know what the initial height is, don't we? I can plug in 0 and I can find out, that this is 80. And now we have our position function.
Isn't this like the same thing we used last?
It's the opposite of it. We're going upward now, starting with the gravity and moving up. Instead of me giving you the position function and you finding derivatives, we're starting with the derivatives and going backwards.
But if we already know that, it's like that standard function, and we just use that.
You ever wonder, how do they ever find those functions on these things that are falling?
No.
What's wrong with you people? Right?
I love it.
That was the wrong answer. You're supposed to be wondering that. Like, I've always wondered when they said, a rocket is flying and the position function is this, find the velocity. I'm like, how'd they get that equation? How'd they know that equation matches up?
They made it up.
It's from this. No, it's from knowing the acceleration of gravity. You can find any equation on any falling object. You can find the equations out. Now you're equipped to model any path of a falling object you want to. Woo! That's awesome.
Yeah.
Have you ever seen, what was that movie with the rocket? The one where the kid...
October Sky.
October Sky. That's why. What if that's you? You caused the fire.
It's definitely not.
Ah, it's a good movie. Okay. Lastly, I'm almost done. Almost done. Quiet down. We have our position function. We've actually answered this part of the question. Find the position function. But we'd ask for one more thing. When the ball hits the ground. When is that?
-80.
When delta x equals 0.
When? There's no delta x in this problem.
Delta y? There is.
Okay, no. When is the position, okay, and when the ball hits the ground? When the ball hits the ground, what height is the ball?
0.
Don't forget, that's what S of t stands for. S of t stands for the position, or how high the ball is up. So we set that equal to 0, absolutely, to find part 2. So we have 0 equals -16 t squared plus 64t plus 80. You can solve this one of two ways. You can plug this into a graphing calculator if you would like to. Press calculate and find the 0 where it crosses the x-axis. Or you can factor.
Let's not say we did.
-5. -16 times t minus 5t plus 1 equals 0. So it would hit the ground either at -1 second or 5 seconds. We're going to talk about the future time, not going back in time. It hits the ground after 5 seconds.
It would be relatively impressive if it hit the ground. -1 second.
If I was using a graphing calculator, I would punch in my equation, very similar to what you see here. I would go to graph. This is what the graph would look like. I would press calculate. I could calculate the 0, pick my left boundary. Oops, that's too far left. Let's try that again. Quit. Graph, calculate, 0, left boundary. Let's say I didn't know. Let's say I can't see my cursor, which I can't. My left boundary is at 2.3, so this is 1, 2. This will be on the left side. I would press enter. There it shows me my left boundary. Right boundary. I want to be higher than 5. 1, 2, 3, 4, 5. It might be 5, it might be 6. So I'm just going to play it safe and press 6. So it's going to find the 0 between these two places. Guess it. Yes, I'm going to press enter. And it calculates the 0 for me. Let me show you what it looks like with the light. Bam. Same answer. So there we go. We're going to stop your homework right there.
Homework.
We're going to stop your notes right there. You have the rest of the period to start your homework.